this test.
Yeah, but we're going to start prepping for tomorrow. Of course, as soon as I say everybody's here, somebody else shows up. Alright, so here's the things that you're going to have to do. And, I got to fix the little spotlight thing with everybody too. Good morning. That's what I wanted to do. Alright.
Are you serious?
What?
I used Ethernet at my house, and now it's popping up now that I'm at school. It's like Ethernet tampering detected. Reconnect the Ethernet connection. Now it's tripping out. So, because the school always thinks something.
Yes. Are you ready? Mathematically, for tomorrow, you have to identify the 9 families of functions. It's open notes, so picking them out should not be super difficult, although it's not going to be like just this guy of the line. Any line that is any line that is straight, which is all lines are straight, is going to be a linear function. I'm going to have them all transformed in some way. You guys had something like that in the homework, and y'all were either absolutely awesome, or you looked like you Googled things because you came up with functions that are not a part of this class, that are like towards the end of pre-cal, and they weren't those functions either. But I could see how photomath would be confused. Because some of my functions looked similar to some functions that were specialized, that were not part of this class. And I thought, oh, even the directions gave you a list of possible names. I'm going to do that, by the way, because I like tricking Photomath and Google. It makes me happy when they get tricked. Especially when it's a problem that's really, really easy if you just take down notes in class and I give you the answers. That's usually my goal.
It's not hard to trick a computer.
What?
It's not hard to trick a computer.
No, it's not. But a lot of people that refuse to write down notes in class or pay attention in class think that it's impossible to trick a computer because they can't do it. That's right.
I'm not gonna lie to you. My problem is I get it in class, but then when I go home, I have absolutely no idea, and then I just lose all hope from there.
You weren't one of these people, Alex.
I know I wasn't one of those people because I lost hope.
But like literally, if it's got 2 pieces that looks like a rational function, it's a rational function. Like that's really what it is. It's gonna just be knocking down and saying, oh, it's this close, more closely related to this function than all the others. All right. We're gonna identify transformations and perform transformations on functions. There's not gonna be a ton of those because we're gonna have those like for the rest of the class, but they're really important to get. So they become the easy questions later on. Identify the domain and range. Classify functions as either onto, one-to-one, both, or neither. I think I forgot to put that on the practice, but that's going to be there. We'll talk about it anyways.
No. You had it on the practice?
No, on this one.
No.
Classify functions even, odd, and look at increasing, decreasing relative things. As Mr. Thomason used to say, I've now checked that off of my box, and my observation should go well. What? Not an actual observation, but he used to say, like, don't just have the objectives written up there. Actually discuss them in class. It's important. Your kids are going to want that. Oh, now I'm having all types of people coming in.
Yay. Identify which family of functions.
It's a Monday morning. All right. So it's stuff like this. Like that guy right there. What family is that one in? Absolute. It's an absolute value function, right? It's not the absolute value function because the absolute value function is the v based off right here. But it's going to move. They're all going to be a little bit different. Mainly because if you Google this, you're not going to get any of the functions that I have listed up there. If you just do like a picture of this, and do an image search, it's not going to be right. But if you like have your list of family of functions, you look at it and say, oh wow, look, only one of them looks like a v. So if you like try to play the math game correctly, it's really, really easy. And if you try to cheat me, you end up like messing up and struggling. That's my goal. My goal is people that try to do the right thing have an easy time and an easy class. And people try to do the wrong thing, get frustrated. What's really ironic is someone's gonna like work really hard at like proving me wrong by not paying attention in class and then still getting a good grade. And that's gonna be their goal. When if they would just write down the things I told them to write down, they wouldn't have any issues. Not that I'm like bitter about people fighting me to their own detriment. All right. Also note, if you ever end up having an earpod that looks like this, if you see like that thing cut off at the bottom, know that you can scroll. I like having more than 2 or 3 options for a question. What guy is that one? But y'all can do this.
That's
Ahead of me.
a cubic.
Not a cubic. You know how to tell me between a cubic and a cubic?
Whoa! Wait a minute, cuz now I gotta go all the way back. Okay, well then, wait,
The
no.
cube root.
Oh my god, that's right.
Okay,
And
this.
here's how you know. A cubic has his hands pointing up and down, right? See these guys gun? The cube root has been shot. His ends are pointing out more than up and down.
The square root's the one that just starts at a point and goes off.
Yes,
Okay.
in some direction. He's the only one that has an end point, a starting and an ending point. Or a starting or an ending point, depending on your point of view. Right, that's a cube root, not a cubic, and that right there is probably the most common mistake with those.
Probably because it looks the same, it's just on its side.
Well, they do opposite things. So like a cubic starts off really, really fast, gets slow, so then picks up speed again. A cube root starts off slow, picks up speed, and then slows down. Even though they're always like going faster, but like their rate of increase or whatever goes like that. I did an analogy. It's on I put up a YouTube channel over the weekend. I'm gonna do a YouTube video to help people out. And I don't know if I posted it to you people or not. I'm just happy to get past it. But I analyzed like all the families of functions, and I did a little bit of an analogy. Let me switch over here for you people. This may be helpful. Oh, wrong camera. This may be helpful for keeping cubics and cube roots straight, because they are similar. I don't want you guys thinking I'm talking about this function now. All right. That is a cubic. This is a cube root. So this is how to think about it. The cubic is like running a marathon. Have you ever like seen someone run a marathon? All right. They start off, or at the very beginning, they take off because they're in the huge pack, they're all together, and they need to get separated in some way. So they're all running fast at first, right? And then after that, they start hitting the groove. They start hitting the groove, and they get tired, more tired, and more tired, right? And then right around here, they're doing the whole refreshment stand thing. So like, they're not going to stop. They're going to keep on going better. Like they're grabbing their water, and they're drinking. I don't even know how in the world they run and drink at the same time. Have y'all ever like seen that and thought about it? Anyone ever try doing that from a cup? Did you end up getting like soaked? Okay, I was gonna say like how you do it and actually get any water in your mouth is just like beyond me. But they keep on moving, but they're going slow during that because they're trying
Well, you don't want to have too much, otherwise you get jelly belly. You just want enough that, your throat isn't dry.
I just
mouth
see
isn't
them.
dry.
And I think about like I run a lot, but we never stopped to go eat to drink because it was wrestling. And we were like, yeah, dehydration is the reason why we're running.
Yeah, you probably run in a trash bag.
No, I don't know. That's what I was like. That's all.
No, wow.
That
Who's
actually
taller and
that,
you now?
No, that actually goes like when I was 15. 15 is the last time I ever wore anything trash bag wise. And I lost a lot of weight afterwards. That was like even when I was good at it. I was like, I realized what I was doing wrong before then. All right. So they're right here, they're drinking the water. They don't actually stop. They're still moving, right? They're going. And then they're going and going. And then they're like, oh yeah, now I'm refreshed. And I'm on the second half of the race. And I'm going. And like all the way down to the end where they're like trying to go as fast as they can. That is a cubic function. A cubic is running the marathon. It's running the race. The cube root is the way, how do I describe it? My brother-in-law and his friend, they both ran, can't remember if it was a whole marathon or a half marathon. Knowing them, it was probably like a tenth of a marathon. But I think it actually was a half marathon. And the whole like starting thing went off and it was like, everybody took off and they were like, oh yeah, I guess we got to start moving. And they were like going slow because their whole goal was just to finish. But they were going, and everyone was watching, and they were going. And then all of a sudden they realized that there was like cameras from like the news people watching all this stuff. And they're like, we have to look good now. So they started taking off, right? So then they were like going, they were trying to pass some people. And they were like, oh, look at this. Yes, video camera saw us. And then they were like, all the cameras are gone. This is boring. I've been here doing this for a long time. But they wanted to finish. So they just slowed up and just trailed off. They're like, all right, this is our pace the rest of the way. Cube root is like, and I like to think of it, cube root is like realistic running. Yes, you have a question, comment.
No,
scratching.
no.
Right? Cube root. Find somebody that makes cube root go with like, the slacker version of the marathon. Although, as my brother-in-law pointed out to me when I called him this, he said, I just ran a half marathon. You can't say slacker and half marathon at the same time. And I said, you're a slacker half marathon runner. Because what's he going to do? He was not pleased with it. And then cubic is like serious person doing it. By the way, fun story. His best friend that ran it with him, I have to share this because this is just awesome. About midway through the half marathon, he realized that it was my brother-in-law, his best friend. He said there was like a 10-year-old, can't remember how old he was, but middle school age boy that was staying back where they were. And his friend told the middle school boy that he would buy him lunch if he made sure that he did not finish last. He was like, I can't be the last, I cannot finish last in this marathon. He said, everyone's gonna like tease me about it, pick on me. He said, I will buy you lunch if you finish behind me so that I'm not last. And the kid did it. And the brother-in-law's friend like bought him like a really nice lunch, whatever, but like, I just think it's funny that he had to bribe a little kid to let him beat him in a race.
Oh my.
That poor kid.
The poor kid, he's probably
No, I was about
he
to
has
say,
a
you
future
gotta
in
bring him
boxing
up.
right there. He's like shown that he will sell out his integrity for a good check. So I mean,
Son, his integrity.
I'm just saying that's how.
Not his integrity. That is called being a businessman. Okay.
So I just think he has a future in boxing right there.
Bro, like, imagine you running a race and then somebody tells you that they giving you a free
I
lunch
wasn't
afterwards.
criticizing him. No, I said that as a
Bro,
compliment.
I would be like, yep, I'm taking last for show.
I'm just saying that's what he did.
The great thing is the fact that the middle school was keeping up with him. That's pretty cool.
And he was on the best. They were doing it they were doing it to like, I think it was like a charity based thing, but they were doing it mainly just to like show that they actually could just go through and finish. Their goal was never to be fast. They're like, just going to get through it all. Alright, so this is a cube root, right? Y'all can work ahead of me. Y'all don't have to wait. A lot of y'all have worked ahead of me.
We were talking for too long.
Well, I will start talking because there are a lot of people that are on the same number as me, not going past me.
How was your weekend? Wait,
Busy.
busy.
Alright. How about this one? This one you should know. It's cubic. It's cubic. It's backwards, but it's still cubic. It's been reflected. That's all.
Wait a minute. Yeah. I gotta go all the way back to 3. Yeah, I got that one. Yeah.
Wow. So many people that are in here virtually, you can answer the questions. You don't have to wait on me. I'm going slow, hoping that you've gone into the quiz thing and have gone faster than me. Number 4, which type is that? You okay with exponential?
Yes.
It's like the one that makes sense.
Good. Yeah, that one's linear.
No, it's not.
Don't miss those.
No, it's not. That's just a big absolute value. You can't even see the other V, like the other side.
I promise I will show you everything that's important or interesting about the functions.
Rational.
Yeah, I got it here somewhere. There it is. Not what I need to click on, although I need to do that too.
So, what are you doing? Step function.
Oh, I'm gonna do it all.
I swear to God, that's how I remember it. Step function.
We don't have a handle to miss anything, and let's see. Are we okay with the family function? Anybody gonna say, no, wait, I don't understand this, don't understand that? So many people that just sign in and don't do anything, it's gonna hurt you later on.
I don't think they're ever even talk to you.
Yeah, I think that is.
It's alright. It's all fun and games to don't understand why your test grades are what they are. Ready, set, answer your name. So, here, this is how you've done. Now do we have questions about family functions?
So you said you had like an analogy. Was that only for cube and cube root, or was that?
This one popped up in my head. I mean, I can probably publish them for everybody else.
Domain and range.
The domain range for this function. It's not the one it basically is. You have to like actually look at it and analyze it. Yeah, they say that.
I need to relearn it. I'm not lying to you. I already forgot domain and range.
So domain is what x's you can range or what y values you'll have as a result. So let's come back over here then. Sometimes interval notation's easier to figure out, while set builder is usually easier to write, but we'll do this since Al says. Let's see. It starts at -4, 1. 1, 2, 3, 4, 5, 6, 7. it really one?
Yeah, it's no negative 4, 1.
And
Negative 3.75. 0.
looks like that,
Yes.
right? So here's what I do, makes it a little bit easier in my mind. Domain goes left and right. So I set up an integer, an interval, right? From where my x values start. Starts at -4,
Mhm.
and then goes on forever, right?
Mhm. So it'd be -4.
And then I do the same thing range-wise. I look and say, all right, where do I start having things?
You can just say up and down.
Yeah.
You want the next?
I've got a value all the way up until I get to there, right?
Yeah.
So my domain, if I'm going to do this in interval notation, is from -4 to infinity, and my range, interval notation, -infinity up until 1. And I'm touching both of those. Or if I see that, I can say, okay, great. As long as x is greater than or equal to -4, and my y's, as long as y is less than or equal to, not negative, just 1. Does that make sense?
Yeah. For this one, it seems simpler because you have a point that it starts at, and then it just continues on. But yeah.
Just write it out.
A lot of times, as far as like if it doesn't have a math type, what you would do is you would have like greater than and then put equal right after it, or it'd be less than and then equal, which looks kind of like an arrow. But you should put an equal sign right next to it.
Oh,
Order doesn't matter.
dude, it's on the keyboard where the comma and the period is.
Yeah. But
Yeah,
yeah, he meant be equal to. He meant
Oh.
Yeah, that one's really.
Also, if you're ever inside Set Builder, you can't always go to the English language and just start writing words. You can write a whole essay there if you need to.
A whole 5-page essay.
I'm good.
So, you know, I've seen some groups of things where you've had like, there just weren't symbols available for what you were trying to explain.
So they had to write a whole page essay.
I wouldn't say that. I would write like 2 or 3 sentences.
Couldn't be me. Infinity.
Oh, because of the symbol. I don't have math type in there, do they?
No.
No, they don't. You want to know why? Because they're trash.
I thought I did when I did this at first.
You know what? I'm just gonna put like INF. There you go.
That'll
Infinity.
work.
Boom. I messed up. Question.
Yes.
You're gonna take off points if we accidentally put like a bracket beside the infinity sign instead of parentheses.
Yes. You can't ever have a bracket with your infinity sign.
Bro, I forget about that stuff.
Parenthesis. The range. Negative. That'll work. Right? -4 to infinity, and negative infinity to 1.
Oh, Lord.
Range is every single value you can have, not just the ones that I point out. I'm gonna point out things that are not helpful.
You realize that these are you, right? Oh, bro, it's only 8:30. Jeez.
You'll be alright.
Alright, we're good with that, I'm hoping?
You don't know how many times last night I talked about quitting school. Dropping out.
Here, if you're a set builder person, this works just fine.
X times X is greater than or equal to -4. Y is less than or equal to Y.
This one works good too, set builder people.
Open-ended questions are the stupidest questions.
Yeah. Okay. Look for increasing, decreasing intervals. Did I give you lots of points and things that are happening?
Relative, absolute. Ooh, so there's only one relative HP. HP.
And yes, you can use the word infinity or INF as Alice was trying to do for infinity if you end up having to get to infinity. And infinity will always have a parenthesis and not a bracket.
Increasing interval. When you're naming the increasing intervals, you put the
Increasing, decreasing intervals are x values.
just the x value.
Just the x values.
Okay.
Going left from right. Going left to right.
For that 0.331, do you have to add that in when you're doing increasing, or can you just go from 0.145 to 2.166?
Sometimes I give you more points than you ever need. So when is it? It is increasing from here all the way until there. Like that is like that because that is the max. That is the top, and then it starts going back down. So yeah, you can ignore that. That's just the next intercept.
Whoa, wait a minute. You're telling me the one below 0.333 is an increasing interval?
It goes up from there.
Okay, but that was the lowest position.
Always travel from left to right.
Yeah, left to right. I know.
That point, it increased.
Yeah, I know, but I didn't think you included it. I thought it would just be 0.33, and then
It doesn't change. It's still going up the whole time through.
I got you. Okay, all right, fine. Dang, just trying to think.
Well, at least you actually talked to him, and other people don't.
So I was thinking about that this weekend when Friday came about, and I was like, it's pretty difficult. And I also don't care enough to remember it either, so that's pretty trash.
So wait a minute, what were you thinking about Friday?
Oh, so I was thinking to myself, I was like, Honestly, if I would like ask more questions in class and actually figure out how to do this stuff, I could do it by myself. But like I was like I'm being too lazy, and one of my friends was talking to me about it, and I was like, yeah, I haven't done just about anything because I I don't know. I haven't had any motivation.
At one point, I was putting in homework grades, and I was like, I need to like stop and eat lunch now. And I was like, no, wait, Alex did this one. This one has to get put in.
Wait, it was the one. It was the one that I did like 2 weeks ago. And I hope you know I did that in class while you were talking.
I was like, this one has to go in because Alex hasn't done it.
Bro, what's my grade? Like a 1? I'm really curious.
I don't think it's a 1.
You don't think it's a 1?
No, it's really hard to get.
I don't know if that's something to brag about.
It's not something to brag about. Trust me, I want to get it up before my mom beats me.
When did you do this stuff? Relearning or whatever?
Like I said, man. So
I didn't put that in as a grade yet.
I was thinking to myself, and
You need to put it over the weekend.
oh,
I know
bet.
it.
You got Alex?
I got 40, cuz. Listen,
24 points.
as I always say, better than a 0.
He's so
Mom,
proud.
that
One,
was
two,
my
three,
little
four.
ass.
1, 2, 3. So I have 3 or 7 zeros though.
Yes.
I only have 1 0 in your
If you
class.
didn't have like half of those zeros, you would be fine.
I know. But again, like I was thinking, I've been lazy, and I was like, you know what? I actually need to learn something, and then just
I'm so proud of that 40.
do something.
Listen,
Listen,
it's better than a 0, honestly.
Okay.
There are people that have done all their homework that have lower grades.
Really?
Their homework just went.
how? Because it's trash. Anyways, not the point. Point is I was about to say. See, that's why I'm happy.
And then get into a test or assessment where they have to be absolutely right. Doesn't even.
I'll put in minimal effort to where some people have actually put in effort, and I have, just
I
about
haven't put in effort,
grade.
they just turn things in.
Anyways, my point is, it makes me feel good. Alright, so don't try to down. But anyway, bro, thank you. Appreciate the support.
All right.
And
So
you know
a
what?
lot of people are either not answering or struggling.
Oh, I was checking my grades. You gotta give me like a minute. Huh? The answers? No, it's not. I know the picture's on the board.
Yeah.
I'm blind though. Can't see.
So I'm gonna start with increasing decreasing intervals because they're fun. It's all x values. So if I remember that, I'm always gonna write them across down here. All right. I'm going to do increase. So like increasing in blue. So this guy right here is an endpoint. That guy right there is where he stops going down. You with me?
Yes.
Gonna be blue for increasing. Then he changes direction here. From here to there, he's going up. So that is 0.145. Note, it's a bracket all the way up until my x value is 2.066.
How long? Why did you? She can't see through.
You can't just look right through me?
No, sorry.
That's ridiculous.
Oh, that's interesting. That makes it a heck of a lot easier, dude.
So decreasing goes from here to here, right? Well, that's zero. And anytime I have an endpoint for increasing, decreasing, it's either going the other thing or it's a gap in the function in some way. So this whole function doesn't have any gaps. Once it starts, it goes on. So every single endpoint is an endpoint, and it's a point of like something happening. So increasing to decreasing, that's 0.145. And then I'm also decreasing from 2.066, because that's an endpoint here,
Infinity.
to infinity.
Yo, let's go! I just got that right.
That's my increasing, decreasing things.
Okay, but would you really have to put that last one though? Because yes, you can infer that, but at the same time, it's also off the graph. Okay, but just because it's going down off the graph doesn't mean that it doesn't go back up. That's my point. There's infinite things that can happen to that line.
If it's off the graph, we assume that nothing else interesting has happened.
You know what? Okay. Fantastic. You know, I love math.
Mainly that is because I've shown you everything that's interesting that happens. If you want to know what this graph actually does, well, it bottoms out. It's technically a piece of a rational function that I've cut off part of. That I cut off with the domain restriction.
Yeah, it looks like you cut the image.
I didn't. I literally just said it wouldn't let x be greater than or equal to this thing and this other function. And it bottoms out at 0 is what it does. It's a piece of it's a quadratic that's inside a rational function. Which is the reason why it has that cool little waviness to it. We'll talk about those things. But I'm only going to show you things like, I'm not going to cut off anything that's a big change or an interesting thing.
Okay.
Eventually, that's the reason why graphical and algebraic math goes together, because like you're supposed to see it algebraically and say, oh, everything that's interesting is going to happen in this area. So I just have to graph this area and know what happens outside of it a little bit.
You want to know one thing that annoys me about math? Is that, back in the day, you just had a formula. And as long as you follow the formula, you were Gucci, right? But now, in all these other math classes, you always got to keep an open mind. Because even though you may be doing the formula, right, you don't want to miss, certain parts of the equation that you would miss, just by having.
I don't follow formulas, just so you know.
Exactly. And that's what I'm stuck on, because that's what I do.
Yeah, I want you to like understand what's happening big picture, and if you need a formula, you'll make a formula.
See,
But you have to know what's happening, because it all works together. It's not like just if we had like a bunch of steps, and that's all we ever did, all you would really know is that section of stuff.
mm-hmm.
But like,
Well, that's what I'm talking about.
but all of that stuff works with this other stuff and this other thing. It's all connected and it all works together.
Yeah.
If you see how they all work together, you don't have to do any steps. It's just like, it's there. It's like this guy right here, decrease, well, A, he's an endpoint. So he's automatically a relative something. Is he a relative max or a relative min?
Relative max.
Let's start with that. We'll just label out the points and we'll say which ones they are. So there's an endpoint. He's going to be something. All right. This x value is an endpoint for increasing and decreasing intervals. If it's an endpoint for intervals, I put 0, 0 here, then it'd be negative 0.2. I was thinking that was at that point. That's the endpoint right there. Y'all could have fixed me on that. I just realized that I saw 0, 0. I was thinking it went with this point, but it doesn't. It goes at that point, obviously. It's negative 0.2. Every single every single x that's an endpoint for one of your intervals is going to be a special relative max or min. So this negative 0.2 is an endpoint. 0.145 is an endpoint, and it's negative 0.063. I'm done writing. 2.066 is an endpoint. And it is also 0.7698. Right? Those 3 points are the only endpoints I had for my increasing, decreasing intervals. Right?
Mhm.
Yes, no, one of those things. Right, so that's gonna be my only thing for maxes and mins. So this guy, Alex said was a max.
That's what I think it is.
It's either taller or shorter than the point next to it, and that guy right there seems to be taller than what's next to it.
Mm-hmm.
Is it an absolute or a relative or both?
Well, according to your thing, it doesn't say any absolute, so I'm gonna go with relative. Like over here on the top left, you don't have any absolute maximums. You only have
Yeah,
relative.
you scroll down.
What? Yo, that's crazy, dog. I'm gonna go with maximum on it though.
What is what?
You already said maximum. Is it relative or absolute?
Oh, no. Absolute. On it.
All right. So what is an absolute maximum? It's the highest point.
Yeah.
So is there no point higher than this right here? Really?
That was a
jump
little-
in the middle of it.
That was a little crooked. Yes, there is.
So it can't be an absolute.
So which means it's relative.
So it's relative.
Oh,
All right. This guy down here, is it a max or a min? The 0.145.
it's a min.
It's a min. Relative, absolute, or both. What do you actually, if I'm gonna say absolute, you can't be only absolute and not relative. So, is it relative or absolute?
Absolute.
Absolute. And this point over here, max or min? Max. Relative or absolute?
Absolute.
That makes sense?
Mm-hmm. What's up?
I'm looking at them.
Oh,
Because I'm not looking at them, but I'm picturing them. We okay with those? I'll let Alex write. I'll let Alex write. This is not showing the way I thought it was gonna show up.
what?
I thought, that when I give like that screen to you guys, I thought that you get to write over, right next to where I put stuff, like how I had stuff like all spread out.
Oh no.
I thought it would give y'all the space to write in each one.
No, it doesn't.
That might be better as a drive than as a typing thing. I think I might do that for domain range also. Let y'all draw it. At least then you can make the symbol.
All right.
You good? All right, do these. These all should be straight from your nose.
Ooh. I'm
If
pretty
they
sure.
aren't, then you should just remember what even or odd mean and just make it work off of that.
How do you know if they're neither?
There's like two that are even.
No, neither.
Yeah.
It's not even and it's not odd. So like, evens would be things where
Yeah.
they do the same thing on both sides.
Mhm.
Odds are where they do the exact opposite thing on both sides. Neither would be if something is different.
Oh.
Um,
So like,
and she said there's like two that's neither, there's three. What?
exponential neither.
Exponential is neither, because on this side it's going flat and this side is going up, and it's like, not
square
quite
root.
opposites or balances, it's doing different things. Yeah, there's three that are neither.
Mm-hmm. Step, square root.
And because of transformations, some that are even or odd can become neither.
Why would, what's it called? Step be neither?
It's mainly because of two things. One is their endpoints. When, if they were to be reflected to the origin, the open circles would have to flip over to the other side, and they don't. Or that very first line that hits the origin that goes through, in order for it to be even, it has to, well, even is just not doing that, it's doing like this. In order for it to be odd, when it goes to the origin, there has to be one that's also on the x-axis on the other side, and there's not, it goes straight down. So that middle central piece is what messes it up. God bless you.
Oh.
See if we can. So this, if it's gonna be to the origin, this piece right here, going through the origin is two spots left, would have to also have something over here. And there's not, it's down here. And like all of these guys would have to be over here in order for it to be odd. And then everything shifts off of that. But because it goes straight down here, it doesn't quite line up right. That's why. It wants to be odd. If you just look through the middle of those lines or just like kind of generically at them, it feels odd. It almost matches up perfectly. Which ends up making it easy because you end up remembering that. You're like, oh yeah, you're not gonna trick me on that one again.
Oh, no, go back.
We did it.
I thought that was a, that's not now. Really? That's a quadratic, man. Ah, haha, quadratic is still easy. South Korea.
is the wrong answer. They did not accept my answer. That's not nice. So there's 9 functions, 3 of them are neither, at least 6. 4 of them are on linear, spheric, cubic, rational, yeah. And 2 of them are even. That should help you out a little bit. What?
Absolute and quadratic.
Absolute and quadratic, they're the only ones that are even. You get into pre-cal, it'll be close to the same thing, sine will be even, cosine will be odd.
Sir, we did that last year.
Your geometry classes sometimes get there. Most geometry classes end up getting there, but you don't do the same things with sine and cosine in pre-cal. You treat them as algebraic functions. You see them like geometrically a little bit too, but they're like a graph, and you do a lot more with them. Logistics and logarithmics will also be neithers. I think that's the only 4 functions that you don't see. You won't see step functions in pre-calc usually. So you lose 1 and you gain 4. But they're very different from each other. They're very distinctive and they're easy to like differentiate. The only thing that messes some people up is some people will think that a square root function is a logarithmic. The only difference between them shape-wise is that a logarithmic doesn't stop going down. But if you graph it with technology, sometimes it'll get so steep that it'll just stop graphing it, and then your photomath will think that it's a logarithmic function, but it's really a square root. Or it'll think it's a square root when it's really a logarithmic. All right, here's how you did. Ask questions, tell me to go back, check things out, scroll and see. Of course, if you scroll, you can't see which function it was because it doesn't include the picture. So you want me to say, hey, this one, number whichever. And you may even have to count them. 1, 2, 3, 4, 5, 6, 8, 9. No one's asking me questions. Fine.
Which one would be an absolute value function?
Yeah, they're all absolute value functions.
Okay. But it just depends on where it moved.
Yeah, I'm asking where it was.
Has been vertically reflected. That's pretty neat.
I realized we didn't stress transformations as much as I used to, so.
So it's either that one or that one.
Well,
It's this one.
Yep.
Oh, yo. Wait a minute. This is the one where if it's inside the lines, it's a line, right? And it's the opposite. Yo, I'm so happy I remember that. Bro, I was about to trip hard.
Alex,
Yeah.
there is an advantage to being inside the classroom physically instead of being here on computer.
Okay, so I'm not gonna lie. I should be wearing like contacts or glasses. So all of that is like beautiful, but I cannot see it. So unless like I legitimately get up, take my computer, and walk around the classroom to help myself.
Okay.
Yeah.
So, what if we have a picture of the boards on, like, what if we need to use that in our look at something?
I was about to say, what if our notes are on our phone? Is that
So-
accessible?
I would normally say, no, you have to have them written down in some way.
Yes.
But my go-to fallback position is if you were a virtual student, would you have access to it?
Yeah.
And if you were a virtual student and you had your notes there, you would.
I mean, I'm not
So,
saying,
okay.
I'm not saying I might have to, or.
Well, you've
might
already
need it,
said,
but I'm
you've already.
saying, like, if I have to use it, could I look at it?
So my fallback is, if I was a virtual student, would I have access to it? Okay.
I was about to say, I mean, he knows you ain't gonna cheat because you too good to cheat. One, and two, he already made it so the questions are stupid and you can't cheat. So, you know.
Yeah, well, that's not quite true, because like you literally you could sit there and like look up every single one of those functions, and I tell you, and you could graph them all, and then remember what those words mean, and look those things up, and you can spend 15 minutes on that one question. And
Trying
eventually
to
get it right. Yes.
And then when you get down to the final exam, you go,
Well, then you end up, you know, then you're on like hour 4 on the test. Because you were trying to cheat and save time. And you know what? You then deserve to take a 4 or 5 hour test.
Vertically shifted up 3 units. Let's go. Down 3 units. Yes, sir. Shift to the right. These has to be X.
What time is it? Okay.
You probably about to get like a 3 out of 6. Let's go. Yo, no!
I don't know if I need these anymore.
Yup, that.
And we have like the most disease-free chalkboard in the school system. That works. Oh, it's almost there, almost there, almost there. All right. Bisexual. Yellow, yellow, yellow. There it is. All right, I'm going for everybody because transformation are either okay or not so okay, or a lot of people just mentally check out and say, "Oh, I'm not doing it."
I had it last week, but I got kind of.
Yeah. So let's make some quick notes. A vertical reflection across the x-axis. That happens anytime we are multiplying by a negative on outside. So let's pick a family, any family you want. Absolute value. I have a negative on the outside. Negative any number you want. But so there's a negative outside of those absolute value symbols, there's a vertical reflection across the x-axis.
Yo. So even if it's just a negative, it's still one.
Correct. Yes. Yes. A horizontal reflection across the y-axis?
Honestly, I don't know.
Multiplying by a negative
I mean,
on the inside. So, multiplying on, exponential is a good one. Yes, horizontals are inside with the x. Yeah, verticals are outside.
I might be back, not sure.
Probably correct. You will know around 9:30. In class, you'll know if you're back. Exponential is a good one. Because it actually shows differently. That's where the negative is right there with the x, in front of the x. Vertical stretch by a factor of multiplying by a number that's bigger than 1 on the outside. Give me a function family, anybody. Don't ever pick linear only because linear, all horizontals and verticals end up looking exactly the same.
All right. Yeah.
Rational, okay.
I don't appreciate you taking it.
Vertical shrink by a factor or something? Proper fraction. Or dividing by numbers on outside.
Quadratic.
Okay. So like that would be this is off camera or not. Those are the same thing, right? X squared over 2, I'm dividing by an integer, or 1/2 times x squared.
Multiply by
Proper fraction. We're dividing by a number.
okay, yeah, so it's dividing. Yeah. Number outside.
Horizontal shrink, remember your line x?
Yep.
Multiplying by a number bigger than 1. I'm not gonna write in dividing by a fraction because we're not gonna be doing that. On the inside. You're not gonna see this very often at all. It plays a role with functions that are neither even nor odd, so, and not even really all of them, because it doesn't mess with square root functions. Does it? Square root functions can be reworked so that they're not, so that if they're a horizontal stretch or shrink, they can affect vertically. Same as I think for exponentials. They affect step functions. Step functions. In this class, step functions are the only times that you'll have horizontal shrinks and stretches that won't show up as verticals, as you won't be able to deal with as verticals. I think that's about it. In pre-cal, the trig function sine and cosine, they will show up differently. So like, you have to be careful of them. All the other ones you can rework so they're not. Now you can make them horizontal stretches and shrinks and deal with them that way, but we typically won't because they're trickier. But for instance, horizontal shrink. There we go. That says shrink by a factor of 1/2. I'm not going to give any of those to you tomorrow because they are tricky. Because what you're let x is lying to you. It looks like it's multiplying by 2. It's really multiplying by its reciprocal. And that's not really an algebra 2 standard. It's a pre-cal standard. Whenever they go from your next class, you'll have, in pre-calculus, you'll have all the exact same transformation stuff. And half the class will think that there's brand new, never saw it before. You people, if you've been paying attention to my class and have just been logging on and ignoring me, will only have this thing right here as the only thing you have not done a lot of in class. Horizontal shrinks and stretches. Because I won't give them to you, but I am going to mention them. But that's going to be it. You'll have like that one new thing to like learn and absorb and realize. Because in pre-cal, you'll see a number of functions that it actually changes and matters. The rest of them, we pretty much supposed to just deal with verticals. All right, you can picture no people. Take that. Virtual people can take screenshots. That's helpful.
Yeah, boy.
good. All right, let's knock out the second half.
What time we get out of here?
Like
9:27.
9:20 something, I don't know. Apparently I am in a Stephen King novel. I brought my computer to the checks and having tried to change the time. They said, oh yeah, we have to fix it for this other person. We can fix yours. And they stopped and they said, we're not allowed to fix yours. We can't get into access yours. And I said, great. I really have been cursed by somebody.
Or they just told you they couldn't do it because they're lazy.
No. I saw him. He was going through all the steps. He got to the denial page. And I looked at him and I said, yeah, I could get that far. Danny was like, yeah, I should have known that it was going to be a bigger issue if you, yes. If you were struggling with that. That was horizontal stretch was last. Yeah. That was horizontal shrink.
Time change itself, like the clock goes backward or forward, whatever it is.
Oh, you mean like when daylight savings time and all that stuff happens?
I think the government does that.
I don't remember.
Like next month, I think.
It's sometime like when we get, it's really close to beginning of spring. I used to keep track of it and know it. And then sometime during the early 2000s, we changed when our standard dates were. And I was like, I'm done. I don't even keep up with this anymore. I'm finished with it. And now I can't remember what the old times were. But it used to be easy, like, it was really close to the first day of fall, really close to the first day of spring. It would change them.
Says Sunday, March 14th.
Okay.
What's March 1st now? It's 13 days.
Next Sunday, Saturday, one of those?
Sunday.
Technically, it's Sunday morning, but like it always happens at like 2 a.m. or something like that.
Then it goes to November 7th.
All right, you ready? Horizontal stretch by a factor of whatever, that is dividing, that says dividing by a large number. Large for us is anything bigger than 1. Or multiplying by a proper fraction. As long as you remember that your x does the exact opposite of what you expect, that explains stretches and shrinks. Multiplying by a half makes something bigger. Multiplying by a third makes it even bigger than that. Multiplying by 2 makes it smaller. It always does everything weird. And again, the step function is good for showing that. The horizontal stretch would be 1/3 x. Vertical shift up units. Adding a number on the outside. You like the quadratic? We'll go with the quadratic.
Hemingway,
Yes.
what's the point of Records Day?
That's a day for teachers to turn in all the grades and all the paperwork and all the stuff that associates like ending a thing and going to the next section. Is it at the end of the 9 weeks or is it the end of the semester?
What?
Or are you just asking in general?
No, not your class. He put in a 0 for something that I did, well, the whole class did, and he knows this, but he still messed it up.
Oh,
I have to go and fix that.
we are good at that. Horizontal shift to the left.
Let's go. He exempted me from whatever that is. Yes, cool. Oh, Lord. Well, so much for Records Day for Homeboy.
Alright, that screenshot, camera people, note people, then go back and fix your transformations. If you need to fix your
Wait,
transformations.
can you turn it in? Because I honestly want to see how good I did. Like,
Can I turn it in?
yeah,
Oh,
like,
you hit the little share button?
yes, the share hand or whatever. I got a 66. I got a 4 out of 6 with it.
5 out of 6.
You got a 5 out of 6?
Yeah.
Word.
I hope that I didn't miswrite anything now. Yeah, it's close to time. Vertical reflect across the x-axis, that means I've been multiplied by a negative on the outside, right? In order for reflection means there's a negative being multiplied somewhere, or a negative that would get distributed in some way. So that guy being in front, that makes it a vertical reflection. Vertical stretch by a factor of 3, that means I'm multiplying by 3 on the outside.
That's the one I got.
Vertical means outside. Shifted up 3 units, that's adding 3 on the outside. Vertical is like very much outside, I think like, especially in the south. V is vacation. Vacation, you go out, right? Vacation starts with V, the bell just rang on us. Horizontal is like staying in home. Inside. Down 3 units, as you guys can go. I'm just finishing up, making sure I get everything here right for my notes version. Left, plus 3 on the inside. Oh, hopefully I didn't change any of my numbers on accident. Nope, that was it.
See, Hemingway.